So now we're going to solve absolute value inequalities. What are those? Those are inequalities with absolute value in them. Right, so we've done absolute value equations before. Now remember that when you have an absolute value equation, it has two answers, right? Because x could be 7 or it could be -7, right? Both of those make it true. So there is a positive and negative solution. So you have to solve the more complicated ones twice. You do right? 3x minus 9 could be positive 12, but if 3x minus 9 equaled -12, that would also make that true. There are two solutions. So we solve it twice. You end up doing the same thing, adding 9 to both sides. Here you get 3x equals, what, 21. Divide both sides by 3, and x equals 7. On this side, you get 3x equals -12 plus 9 equals -3. Divide by 3, and x equals -1. So x could be -1 or +7. Notice that the answers are not always opposites. And then we are going to combine that with inequality. So here's an and inequality. 2x minus 7 is greater than 1 and less than or equal to 9. We solve this by doing things to all three sides. And we get 8 is less than 2x, which is less than or equal to 16. We divide all three sides by 2. And we get 6 is less than, oh no, 8 divided by 2 is not 6. 8 divided by 2 is 4. 4 is less than x is less than or equal to 8. Here is an or inequality. You can't write those. This is a single for the and. For the or, we can have to solve them independently. So x is less than or equal to -8 minus 2 is -10. Or, we can't leave that out. Divide both sides by 6. X is greater than or equal to -4. So this is what we're going to solve. So how do we do that? Well, it's still going to have two solutions, right? But we have to flip the symbol for the negative solution. Let's see that, right? X could be for this side to be greater than 5, right? Any number greater than 5 could be a solution. Or any number less than -5. We flip the symbol for the negative solution. Right? So let's graph this. So x could be 1, 2, 3, 4, 5, right? Because 5 wouldn't make it true, but 5.1 would make it true, and 6 would make it true, and 1,000,000 would make it true. So all of those numbers would make it true. And then 1, 2, 3, 4, -5. Any numbers less than -5, right? Because -6 would make it true because the absolute value of -6 is +6. And that's greater than 5. -900 would make this true because the absolute value of -900 is +900, which is greater than 5. So notice I wrote the word or. This is an or inequality. So now let's look at this one. X is less than or equal to 3. So what numbers would make that true? Well, all the numbers less than or equal to 3 would make it true. So 1, 2, 3. All these numbers, right, would make it true. But wait a minute. Well, all those numbers would make it true? Would -100 make it true? No. -100 would not make it true. Okay. So we have to flip the symbol, and the numbers that are greater than or equal to -3, wait, 1, 2, -3, great. Oh, wait, this is not, let's reorder this. X, right? If the only numbers that make that true are between -3 and 3. This is an and inequality, right? Because 3 will make it equal to 3, right? Absolute value of 3 is equal to 3. And -3 will make it true, right? Because the absolute value of -3 is 3. But any number over here or over here will make it false. So the answer to this is, you could write it either way. I typically write the -1 on the left, but don't have to. right? X has to be less than or equal to 3 and X is greater than -3. So this is an and inequality. So it could be either one. Now here's a shortcut. When this is a greater than symbol, it's going to be or. When this is a less than symbol, with one exception we'll talk about, it's going to be an and inequality. All right. So is less than creates and. That's what I just said. And is greater than creates or. So let's see this. So this is greater than. So it's going to be an or inequality. So x is greater than or equal to 4, or x is less than or equal to -4. We flip the symbol for the negative solution. And then we're going to graph that. So 1, 2, 3, 4, open, close circle on 4. And 1, 2, 3, -4, and close circle on -4, right? The number is bigger than 4, 4 or bigger, or -4 or smaller will make this true. All right, is less than creates an and inequality, right? So I'm going to write this one over here. X is less than 6, or and, my goodness, x is greater than -6. And I could have written it like that as well. Either way is fine. And so then to graph it, right, you're going to 1, 2, 3, 4, 5, 6, open circle. 1, 2, 3, 4, 5, -6, open circle, and it's the ones in between. All right, so to solve this, you have to solve it twice. Once for less than 12, and once for greater than -12. Okay, so add 5 to both sides. X is less than 17, add 5 to both sides. X is greater than -7. Greater than -7, this is an and, it's in between, right? X has to be between, right? Has to be between those two numbers. Either way, you could have written this. Anytime you have less than, but also I could look that X has to be between 17 and -7. So it's an and inequality. Here we're going to do 2x minus 12 is less than or equal to 36. And we're going to do 2x minus 12 is greater than or equal to -36. So we add 12 to both sides. 2x is less than or equal to 48. Divide by 2. X is less than or equal to 24. And then we're adding 12 to both sides. 2x is greater than or equal what, to -24. Divide by 2. X is greater than or equal to -12. Again, it's a less than. This is an and inequality. You can write it either way. Right? X has to be between -12 and +24. Okay, so we have, just like with equations, you want to isolate the absolute value. So we're going to isolate the absolute value, right, first. That means get the absolute value by itself. So we're going to get rid of this add 10 first. Then we're going to solve it twice. So we have x plus 8. The absolute value of x plus 8 is greater than 14. And now we're going to do it twice. All right. Please do that first. It avoids a lot of problems. And so we do it twice. We subtract 8 from both sides. X is greater than 6. Subtract 8 from both sides. X is less than -22. Notice these are going in opposite directions. Also, this was greater than, but greater than 6, less than -22. Those are opposite directions. The only way this could have a solution is if it's an or inequality. Once again, we have to isolate the absolute value, so we're going to divide both sides by 3. And we have absolute value of x is greater than or equal to 4. Then you do x is greater than or equal to 4, and x, or x is less than or equal to -4, right? And the graph of that is 1, 2, 3, 4, closed circle, 1, 2, 3, -4, closed circle. Right? There's no overlap. The only way they can have a solution is if it's an or inequality. All right, the distance between two numbers on a number line is less than 5. Okay. One of the numbers is 2. Write and solve and graph an absolute value inequality to find the possibilities for the other number, right? Right, so the distance between numbers is the absolute value of their difference, right? It's the absolute value of their difference, the distance, right? If you have, just give you an example, if you have -6 and 2, right? Those are 8 apart because 2 minus -6 is 8, and then -6 minus 2 is -8, but either one could represent the distance between -6 and +2. So in this case, we have +2 in x. I don't know, I just made up 6, so we have to solve it twice. Now could you reason this out and figure it? Of course you could. It's 5 away from 2, but we're just showing you a use of this. So less than 5 or greater than -5, right? We flip the symbol for the negative solution. We add 2 to both sides. So x is less than 7 or x is greater than -3. So where's, right? One of the numbers is 2. And the other number could be, right, -3, or it could be +7. Both of those are 5 away. Is less than 5. So all the numbers, right, so the solution to this is open circle on -3 and 7. They're both 5 away from 2. And then all the numbers that are less than 5 away from 2 are in between. This is an AND inequality. So it could have been written like this. All right, so now it's greater than, so hopefully you will realize it's an OR inequality. So one of the numbers is 3. We don't know the other number, and is greater than 7. That's the absolute value inequality we're solving. Right, so we're starting at the number 3, and the things are more than 7 away. Right, so x minus 3 is greater than 7, x minus 3 is less than -7. Right, x is greater than 10. Right, so some number greater than 10 is more than 7 away from 3. And x is less than -4. Is greater than 10 away, and this is an OR inequality. What numbers could make absolute value of x is less than or equal to -2? True. Well, let's put, say, 5 in there. Is 5 less than -2? No. Well, how about if we put -5? Well, that would be absolute value of that is +5, still not, right? There's no number that can be there's no number that makes this true. This has no solution. Now, so if there's a negative number there, once you have isolated the absolute value all by itself, yeah, like that, then there's no solution, okay? But isolate the absolute value first. So, here, x is greater than or equal to -3, right? So you put -10 in there, right? That makes +10, so that would work. +10 works. 0 works. Yeah, well, every number works, right? Every number, because this side is always positive, every number you put in there will work. This is all real numbers. All right, so we're not going to bother to graph either of these. So be wary, all right? You have to look. You have to look over there and see, just because it's negative, 1, you have to isolate the absolute value first before you think about this. And 2, it could be no solution if it's less than a negative. And it could be all real numbers, and I have to spell real correctly, if it's greater than a negative number. All right, so there's a negative number up here, but let's see. So 3x is less than -12, and it doesn't matter. Once there's a negative number there, this is isolated. There's no way this is going to be less than negative 12. There's no real solution to this. And this is isolated, right? It's an isolate, and so it's always going to be greater. This is all real numbers. Right, so let's practice. You should do all of these. So absolute value of x is greater than or equal to 1, x is greater than 1, and x is less than 1. And this is going to be an OR inequality. So we put it's greater than or equal or less than or equal to. So solid things on that's less than or equal to negative 1. And then we're arrows on both. Right? The only numbers that don't make this true are between 1 and negative 1. X is less than 6, and it's going to be an and. X is greater than negative 6, and we'll see that. 1, 2, 3, 4, 5, 6. Now, it's easy today, but 1, 2, 3, 4, 5. I tend to graph these, even when I haven't done them in a while, I'll graph them, and that will reassure me whether I should be putting and or in there. Because, right, if it's in between, it's got to be an and if there's going to be a solution. And the ors usually point out to both sides. All right, so here we have x plus 8 is greater than 6. We have x plus 8 is less than negative 6. We subtract 8 from both sides. X is greater than negative 2. Subtract 8 from both sides here. X is less than negative 14. So less than negative 14, greater than negative 2. The only way that's true is if it's an OR inequality. All right, now here, look at this. We have, before we do it twice, and this tends to be the major mistake on the test, is people forget that you have to isolate the absolute value before you do it twice. You get there, then you do 2x is less than or equal to 16, 2x is greater than or equal to negative 16. Divide both sides by 2, x is less than or equal to 8, x is greater than or equal to negative 8, and this is an and, it's in between the two. The distance between two numbers on a number line is greater than 32. One of the numbers is 6, so that is the absolute value we're solving. So x minus 6 is greater than 32. X minus 6 is less than negative 32. We add 6 to both sides. X is greater than 38. X, add 6 to both sides. X is less than what? Negative and 12, 6, 26. Less than negative 26, sorry. And so this is an OR inequality, right? One of the numbers is 6. The other number has to, for it to be greater than 32 away, right? 6 plus 32 is 38. 6 minus 32 is negative 26. So this one over here, it's x plus 7. Wait, there's a negative number here. This will never be less than negative 6. So this is no real solution. And over here, it will always be greater than negative 6. So this one's all real numbers. All right, good luck on the homework.